Previously, we covered the core foundations. Now in part 4, we tackle solar flares explained. What actually happens when the sun erupts? Part 4, how we predict solar flares, space, weather forecasting. YouTube script. The 1859 Carrington event showed us what happens when we're caught completely off guard by a massive solar storm. But what if we could see these eruptions coming before they hit us? I'm back with part 4 of Solar Flares Explained, and today we're tackling the question, how do we actually predict solar flares and space weather? The answer starts 150 million kilometers away, with a fleet of spacecraft that never blink. Right now, satellites like SOHO, SDO, and STEREO are watching our sun around the clock, monitoring every bubble of plasma and twist of magnetic field that might signal trouble ahead. The Solar Dynamics Observatory, or SDO, captures images of the sun every 12 seconds in multiple wavelengths of light. It's looking for the telltale signs that a solar flare might be brewing: sudden brightenings, magnetic field loops, stretching and tangling, active regions growing more unstable. Meanwhile, SOHO uses something called a coronagraph to block out the sun's bright disk and watch its corona. That's where we can actually see coronal mass ejections launching into space. When plasma clouds start racing away from the sun at millions of kilometers per hour, we know Earth might be in their path. But here's where it gets tricky. Solar physicists can spot the magnetic field changes that often precede major flares, sometimes hours, or even days in advance. They're looking for what's called magnetic reconnection, when tangled field lines suddenly snap and release enormous amounts of energy. The problem is, not every magnetic tangle leads to a flare, and not every flare produces an Earth-directed CME. This is why space weather forecasting is still remarkably difficult, despite our advanced technology. Here in the UK, the Met Office runs the Space Weather Operations Centre, one of several facilities worldwide that tries to make sense of all this solar data. They're issuing warnings to power grid operators, airlines, and satellite companies about incoming solar storms. When forecasters spot a major CME heading our way, they can usually give us between 1 to 3 days warning. That's enough time for power companies to adjust grid operations, for airlines to reroute flights away from polar regions where radiation exposure is highest, and for satellite operators to switch their spacecraft into safe mode. But unlike terrestrial weather forecasting, space weather prediction is still more art than science. We can tell you a solar storm is coming, but pinning down exactly when it will arrive and how strong it will be remains frustratingly imprecise. The challenge is that we're essentially trying to predict the behavior of a massive ball of plasma held together by invisible magnetic fields, based on observations from millions of kilometers away. Every solar cycle brings surprises, quiet regions that suddenly explode with activity, or seemingly dangerous magnetic configurations that simply fizzle out. The good news is that our forecasting capabilities are improving. New satellites are being planned. Computer models are getting more sophisticated, and we're learning more about the sun's magnetic behavior with each solar cycle. This matters because our increasingly connected, technology-dependent civilization needs all the warning we can get. The difference between a manageable solar storm and a catastrophic one often comes down to whether we saw it coming and had time to prepare. Next episode, Part 5 explores the next key question. If you're finding this series useful for understanding our relationship with our nearest star, consider subscribing. It helps the channel and means you won't miss the rest of the series. That is Part 4 of Solar Flares Explained, what actually happens when the sun erupts. In Part 5, we explore the next key question. Subscribe so you do not miss it.